Before we start, let's review some properties of matter, like mass, volume, and density. Mass is the amount of material in an object, and it is also referred to as the weight. It can be found by using a triple beam balance and is measured in grams. Volume, on the other hand, is how much three-dimensional space a substance like a solid, liquid, or gas can contain. That can be found by using a graduated cylinder or a simple equation like base times length times height. Lastly, density is the measure of mass per unit of volume. This can be found using the simple equation density equals mass divided by volume. Now that you understand the key concepts, next we will be collecting data. Everyone split into groups of 4 and measure the volume of your suitcase. Yep, we're going on a vacation. You could find the volume by computing the length times width times height in centimeters. Next, you will have to place a few objects into your suitcase and find the mass by placing that suitcase on the scale. Remember to pack lightly so that you could take home souvenirs from your trip. Once you have put what you want in your suitcase, the next step is to find its density. Density, remember, can be found by the equation mass divided by volume. Now, before you guys will split off into your own groups, I will show you an example of what you guys will be doing in class. Lauren, Bob, Jill, and Henry are the 4 participants, and they each have their own suitcase. As you see by what I've already created in the Excel, we have Lauren right here who has a suitcase with a volume of 20 centimeters cubed. Bobby has a suitcase of 60 centimeters cubed, Jill 100 centimeters cubed, and Henry 88 centimeters cubed. So here we can see that Lauren has the smallest suitcase and Jill has the biggest suitcase. After that, we know that the volume doesn't change, but the mass could change. So we have things in our suitcase like clothes, shirts, shoes, anything we need on vacation. So here we have that being weighed in grams. Lauren had 40 grams, Bobby had 100 grams, Jill had 68 grams, and Henry had 100 grams of things that they would have in their suitcase. So now that we have the mass and the volume given, we have to remember that density equals mass divided by volume. So if you were to pull up your calculator, you could see that by doing, clear that out, 40 divided by 20, because 40 was the mass in grams and the volume was 20 centimeters cubed, that makes your density 2 grams per centimeter cubed. Now, if you were to compute that in your calculator for the rest, you have, for example, 100 divided by 60, which is 1.66, and here you see the answer right here, 1.6 is the density. Now, once I was done with this, I computed the rest of the numbers and I made a graph, and now you can see that the volume is in the blue and the mass in grams is in red, and the density is the little green parts. It's hard to see, but if you relate it to the numbers on the y-axis, then you know what the value actually is. Now, what we're going to be learning from this project is that when the volume stays the same, because the suitcase is the same size, you could put more objects into your suitcase and that will change the mass. When the mass in the suitcase is changing and the volume is staying the same size, that means that the object is going to be becoming more dense. If you look to the chart to the right, you can see in the volume section, Lauren's suitcase stayed the same at 20 centimeters cubed, 60, 100, and 88. All these numbers are the same. But if you look at the mass, let's say Lauren went on vacation to Florida and she added snorkels and seashells, and so the mass got built up to 165 grams. That means her density is going to change, and if you take your calculator again and do 165 divided by 20, that gives you the new density of 8.25. If you look at this new graph down here, you could see that the density is higher. Even though the y-axis range is different, we know that the more mass in the same volume makes the object more dense. Okay, so the next thing I will be teaching you guys is how to make your own graphs and your own tables. Say you had a new group of 4. We could come and the names could be Katie, Ben, Rebecca, and John. Now, these are the 4 students, and when you come up here, this will become your three bars of volume, mass, and density. Now we have volume that you type in, and you want to do the unit so you know it's centimeters cubed. So add that all in there. Mass is in grams, and density we know is grams per centimeters cubed. So by computing the length, width, and the height of each suitcase, you'll be able to find the volume. So we could say Katie's suitcase, put the calculator, had the length of 6 centimeters, the width of 25 centimeters, and the height of 2 centimeters. So that makes it a volume of 300. So after finding Ben, Rebecca's, and John's volume, say theirs were 345, he had a big suitcase, Rebecca's was 115, and John was 25. You just want to make sure you have all your statistics in there. And then the mass could be, let's say, 100 grams, 300 grams, 26 grams, and 80 grams. When you look at this graph, one thing you could realize is just because the volume is big doesn't mean that the mass has to be big, because the suitcase could be big, but there could be only clothes inside, where one suitcase could be small, but it could be holding really, really heavy rocks. And that will put an effect on the density. So now, to find the density right here, you'll do 100 divided by 300, which is 0.33. So that means your answer is 0.33. If you come to the next one, we have 300 divided by 345 to find the density, and that's 0.86. The next one will be very small density. It's 26 divided by 115. That's 0.22 grams per centimeter. And lastly, we have 80 grams of mass divided by 25 centimeters cubed, and that becomes 3.2. So as you can see, there's a lot of mass in this small space. Now, in order to improve this project, what we could do is see what happens when mass changes, and when mass goes up, the density is greater, but if the mass goes down, and maybe say someone lost something on the trip, the mass, and when it goes down, the density will change. So if we want to make a graph of this, all you have to do is drag over all these objects, go over to the gallery, press charts, and here's a bar chart. Here you go, it just pops up. And you could drag it over here, so you have the density is in green. It's very hard to see just because of the density being so little, but that's because density will always be less than the volume and the mass. So that's how you make the graphs, and every group will have their own different answers, and depending on how much stuff is in your suitcases, that will put an effect on the density. So after conducting this experiment, we could come to the conclusion that if you put more mass into the same volume or the same suitcase, then the suitcase will become more dense, and if you take clothes, shoes, and other objects out of the suitcase, it will become less dense. Now, this was a fun experiment because you got to use Excel and create graphs. The best thing about graphs is you could visually relate what volume, mass, and density can do and how they relate to one another. For example, just because Katie's volume was 300 and the mass was 100, it made their density 0.33 grams per centimeter. However, say if you were to change the mass to 200 grams, I'll show you right now, it will affect the density because 200 grams divided by 300 makes the new density 0.66, and that means that when the mass went up, so did the density. And now one thing that's great about these Excel graphs is you could create so many different experiments. For example, if you wanted to see the density of a pop can, you could have a pop can floating in water, and students could use volume and fill up as much as the pop can that they like. Say they put 1 liter of pop in the pop can, and the more it would float above the water, the less dense the pop can would be. However, if there was 6 liters of pop in the can, well then the pop can is more likely to sink to the bottom. So certain things like this, you could create different experiments, and in the end, it's a great way to reflect different scores and show that you know how to use units, and you could work with Excel and also work with different group members. I hope you guys learned a lot, and hopefully you could use this in your future.